know, most data center designs are going to leave you hanging about layer 3 or after. Now you want a little geographic diversity, a little bit of a distance between your data centers? Forget about it. Welcome to your data center design show. It's no excuses, TechWiseTV.
You know, the great thing about Cisco Live is, from a TechWise perspective, is the stories you run into that you really didn't know were actually stories. So I actually bumped into Wayne. Him and I were actually talking, and he designs a lot of the CVDs that we do out here. But then he said, hey, have you seen our new business continuity CVD? I'm like, no, dude, I haven't seen it yet. And you know, what are we doing now that's just different? You know, what hypervisors are we moving this time, you know? He's like, no. We're moving applications. We're addressing everything from layer 1 to 7. And you know, I thought it was a little bit of marketing, but I know Wayne. Wayne's an architect, and I knew he wouldn't, you know, be blowing smoke up my tail. So he has to have something here pretty good. So Wayne, what do you got here, man? What are you guys doing?
Pleasure to be here. Thank you so much. And what we'll be talking about today is business continuity and workload mobility, the next generation of it. What we have is a set of applications, as we know, consume a wide range of resources across a private cloud or a public cloud. Those resources include wide area connections, data center fabrics, L4 through L7 services, hypervisors and virtual switching, and obviously compute and storage stacks. Now, if we want to move an application that's consuming all those resources from one data center to another data center that's maybe 70 kilometers away, it impacts each element of this application environment. So what we see is the legacy, or most of our competitors today, are still dinking around in the last 3 categories of this application environment.
Yeah, that's kind of what I thought you were going to do. I'm like, I'm not interested. That sounds kind of bogus.
Right, exactly. And I'm happy we're able to talk, because right now when people think about workload mobility, they're thinking about taking a VM, moving it to a different host in a different location across an extended cluster, and you include some sort of storage replication, job is done. Not the case here. What we're doing is extending that workload move to the rest of the application environment, because the big question we have for them is, what good is it to move a workload from here to there if you leave the rest of the application environment behind and potentially open up a security hole?
Well, yeah, if you can't move your state, what's the point?
Exactly. So what we've done is we've added to the workload mobility use case the ability to move L4 through L7 services, including security, both physical and virtual services, firewalls, load balancers, IDS, those critical things that are part of the network environment. The data center fabric, being able to preserve network containers, traffic QoS, bandwidth reservation, and most of all, secure tenancy for this sliver of the data center. Since we're moving an application, we also need to be able to move the network container and adjust it accordingly.
Yeah, of course.
And then obviously connections to our external users, both internet and VPN secure connections. So for us, it's not just about these last 3 components, it's about the rest of the application environment. The system, the reality. It's the reality that our enterprises and public cloud providers are in today. So as you look, we'll get right into the CVD. We want to show you what we've done with a realistic application. We're going to be moving a SharePoint application from one data center to another, 70 kilometers away, while hundreds of users are connected. They're not going to know it, and we're going to do it in a completely stateful way across the whole application environment. Our CVD includes 3 different data center sites, 2 across a metropolitan distance, typically deployed, 70 kilometers away. The third, a longer distance, roughly 1,000 kilometers away in our particular design. Yep, the metro data centers, this is a common deployment model. We're trying to map this to the most predominant use cases that we see in our enterprises, private clouds, and public clouds. Okay. So the metro data centers are operating active, typically less than 200 kilometers, but it's more about the latency of the link, right? It has to be less than 10 millisecond round trip latency.
That's right.
The geo-distant data centers is more of a backup or recovery data center. If we lose a metropolitan area, we need to cut over to that third data center for disaster recovery or cold workload migrations. Right. Okay? So that's what we have from a validation standpoint. As you can see in this slide, this is a typical topology for our active metro data center. I'm not going to go through all of the different components, but this includes the best products that Cisco has to offer at each tier of the data center, along with layer 2 extensions. In this case, we use NetApp Metro Cluster for storage replication, layer 2 extensions with OTV, virtual multi-service data center best practice designs. So we're talking about the complete network, top to bottom, including network, services, compute, and storage.
Yeah, I don't see any new stuff. I don't see any new stuff in here at all. I mean, a lot of times you see somebody coming out with this kind of announcement, it's to kind of plug something new we're going to have. It's like, oh, and if you want all this, well, press hard, the bottom copy's yours, you know?
Right.
But you're talking about just doing it with stuff that you probably already have.
Right, exactly. We're taking the best practice private cloud designs, the latest versions of all of this up and down the stack, connecting them across metro and geo distances, and then we're going to show you what we can do orchestrating a move from one site to another.
Okay.
All right? So, what do we want to move? We want to move something someone cares about. SharePoint, typical enterprise application.
You really put it online, you're moving SharePoint because you got a lot of users connected to that. It's a very collaborative type of app. So you could not have picked a more difficult app, I don't think.
Exactly. And what's cool about SharePoint for us is it's number one, not a bogus app. It's a 3-tier application.
Yeah, that's right.
It's got a web, application, and database tier.
Yes, sir.
Traditional 3-tier app. For the database, we're using Microsoft SQL. At each of those tiers, we've got services attached. Firewalls and load balancers. Like you said, high volume throughput is required, so we've got load balancing across multiple instances at each tier, plus your traditional firewall protection so that you can't have a security hole as you traverse this. We have a network container in a traditional way that we've orchestrated to connect each of these tiers and to provide secure segmentation, QoS, all of the normal things that you would expect to be there for a widely deployed business critical app.
Yeah, that's highly transactional too. I mean, your connectivity on the back end is critical based upon how it's interacting with that app so you don't get any corruption and stuff. So that's interesting to see how you're going to do this.
Exactly. So this is a tough app. This is a standard application. What is the first step that we need to do? We need to establish that baseline. So in this slide, this baseline is how we've overlaid or onboarded this application onto our private cloud. We have an orchestrated network container that kind of does the flow of this and carves out a set of resources dedicated to this specific application. So as you can see here, we've got the web tier of our SharePoint application in a public zone. It's serviced by a load balancer and a VSG, a virtual firewall, to protect application tenancy. And then to cross over to gain access to our app or database tiers, you've got to cross a DMZ into a private zone. The private zone for this is protected by an ASA firewall cluster and a specific context within that firewall. We also have load balancing services and VSG tenant protection for those tiers. So this is the baseline. This is where most of our customers are today. They've got a sliver of their data center, their private cloud, carved out for this application. It's got secure tenancy, it's got security, it's got load balancing, it's got network segmentation, and it's a wonderful tenant. Now we've got hundreds of users, thousands of transactions going on this thing live, and we're going to show you how we can move it. So the first step in this move is to move the applications from data center 1 to data center 2. We've moved.
You're doing that hot.
And we're doing that hot. We do a live vMotion of the web, app, and database tiers across our 70 kilometers. Because we have a UCS on this other side, we've got port and security profiles that automatically map the IP addressing scheme, the QoS. Those move with the application. We've got a Nexus 1000V and a VSG that move our virtual services. That happens automatically. The vMotion comes up and quiesces, and this becomes live, and we have a reverse ARP that triggers this layer 2 extension to say, hey,
gotcha.
We've moved this app from this host over on the left to the host on the right. We converge in less than 2 seconds, and what we've done here is we've preserved the connections to the previous container while moving this application over 70 kilometers away. The web, app, and database tiers all have been moved, the virtual services have been moved, and we've done it with 2 important things. Number 1, external users didn't know that we made this move. Number two, we've done it without any sort of manual intervention. All you basically do, Jimmy, is take a vSphere live migration, you go into your vSphere app, you select live migration, you do the live move to a host in that extended cluster in this new place, all of the rest of it just happens in less than 2 seconds.
So is this pretty Lisp heavy then? I mean, you're using a lot of Lisp?
Lisp for right now isn't used because we're still directing our,
you're
our
reverse
users
back
to our original data center. Now in the next step,
gotcha.
as you said, we'll redirect customers to the secondary site. The next step of this is to simply use orchestration, recreate that container on the next site, and within less than a sub-second, we can take a newly created container, connect it to a live web app and database SharePoint application in this new data center, and within less than a second, redirect external flows to that
That's
new place.
unbelievable, man. I got to ask you this, because I know you CVD guys are pretty hard friggin' core.
Right.
Where'd you guys build this at? San Jose and test it out there?
We built it in our Raleigh RTP buildings. It took us over 3.5 months to do validation across multi-site topologies, many use cases, and you can see the latest and greatest Cisco products. This is what we call the next generation of workload mobility. It's not just about moving a VM and replicating storage, it's about doing what we need to support the complete application environment.
I need to see this working. This is a lot of talk here. So I believe you guys got a third-party place that's tested this too, right, in St. Louis?
Absolutely. We're working with a partner, Worldwide Technologies. They're one of our #1 partners. They're using
They're
this.
third party, they're not Cisco.
They're third party, they're not Cisco. They're using this CVD as their reference design to build out business continuity and workload mobility for the hundreds of enterprise customers that they support.
Okay, so here's the deal, folks. Watch TechWise. We're going to go ahead and shut down, and we're going to pack up the crew, and we're going off to St. Louis to actually grab this story. So see you then. Wayne,
Yep.
Thanks, man.
Thank you very much.
Well, just lollygagging on in. Where you been?
Hacking that drink machine over there, trying to get something to drink.
Not supposed to be hacking when we're on a road trip.
Well,
You're
that's the
supposed to
point of
meet
going on a road
Joe.
trip.
He's been waiting.
Who?
Joe.
Joe Weber.
Joe.
Right, come on.
Wait, come on. No, I think it's...
No, just come on. You know, one of the most important resources that I have as an engineer designing solutions are the Cisco Validated Designs. And it's interesting because you think that there's a bunch of Cisco folks, you know, kind of trapped in a lab and we lock the door and throw away the key until they come out with something and just push out a mail slot. The reality of it is, our best designs, no slam on anybody else, actually come from you guys right here at Worldwide Technologies. So Joe, you've got a really pretty darn cool solution here that ties in this whole business continuity thing. What do you got?
Yeah, so what we've seen over the last couple of years, a lot of our customers really wanted to look at business continuity a little bit more in depth and actually come up with a strategy that allows them for things like active data centers, so they can move their workloads around and seamlessly between data centers, whether it for maintenance or whether it for disaster avoidance or even disaster recovery. And what we really came up with here at WWT is we took a lot of different pieces from a lot of different OEMs across different spectrum, and we put them together for a holistic solution that allows us now to provide that active data center that our customers have been wanting. If you take a look at the slide right here, this is kind of the reference architecture that we've put together here, what buckets need to be fulfilled in order for a distributed data center, an active data center to work in a fashion that our customers have been asking about. If we just take a look from the bottom to top, we look at some sort of storage federation or storage synchronization between our two sites. Our data needs to be at the location where a virtual machine or where our workloads are moving to. So that needs to be synchronized. Take another level up and we're looking at the hypervisor or a physical clustering technology between two physical servers. We need to be able to allow those attributes to be at both locations at any given time, no matter where that workload is located at. Take another step up and we're looking at a data center interconnect technology between two different sites. This allows us to move a workload and allow it to reach back to any workload that it may need to communicate with for the service chain. And on top of that, we still need to have some sort of inbound routing correction. We need to make sure that we're directing traffic to the correct data center where that workload or service is located.
Yeah, so, I mean, we've been talking about this for a long time. So, I mean, we brought a whole crew out here. What's different about, I mean, this is, I'm sorry, I'm not impressed. I haven't seen.
So yeah, we get that a lot, from customers, and what they really want to see though is make it operationally easy for them. Before, if you look at some of the other technologies that were out there, there was a lot of scripting, a lot of other things that went involved. What we've done is put some of these other all these solutions together in a holistic fashion to allow our customers to operationally easily move their workloads or allow this business continuity strategy to take place. And that's one of the things we've looked at. If you look at our architecture, we've chosen some products throughout the course of the last 2 years of building out this architecture. And from a storage perspective, we've used things like NetApp Metro Cluster or EMC's vPlex technology to allow storage synchronization. From a virtual environment, we're using VMware's vSphere, and we're also using Microsoft's Hyper-V to compare and contrast those two as well. From a DCI connection, you can use a plethora of different DCIs, anything from dark fiber to Ethernet over MPLS to VPLS or VPLS over GRE or Ethernet over MPLS over GRE, whatever the case may be. But we decided to go with OTV just because it's a cleaner, more, an easier to troubleshoot technology than some of the other ones.
Yeah, layer 2 rules, right?
Yeah, absolutely. And keeping those fault isolation boundaries in each data center is critical to any a good data center interconnect. And then, of course, from an inbound routing perspective, we do use some traditional DNS load balancers with a GSLB or a local load balancer for Citrix, or maybe F5's GTM or LTM provides similar functionality, but that isn't necessarily a live move. So what we've chosen is we've chosen a locator identity separation protocol that Cisco's really been the developer of since the beginning of the Lisp protocol. So we've been using that, and in fact, we've just recently implemented, as of last October, Lisp multi-hop, which was just released not too long ago.
Seriously?
Yeah.
How's that working?
Oh, it's great. Ever since we've been showing this to customers, the adoption of Lisp is going to go up because they see many, many use cases for the discovery mechanism.
Beyond a shadow of a doubt.
Yeah.
It's just that it needs a little bit of work to get there.
Oh,
You're saying that we're pretty darn close, huh?
Oh no, it's available. Lisp
it
multi-hop is available. Yep, as of 6.2.8 on the NXOS. iOS has been out for a little while now, but NXOS it just recently came out a couple weeks ago.
Interesting. Okay. Well, so now you also got a demo to show us too, right?
Oh, absolutely. We like to prove out what we talk about here at WWT. As you can see, if we take a look, this is our environment back here. If you take a look, this is one half.
So this is what we're focusing on.
Yeah, absolutely. This is one half of our environment. The other half of our environment is over in our other data center. So there's physically two different locations between here and there. So let's jump over to the demo and I can show you what we have here. If we take a look over here in the top left, you're going to see our vCenter environment. We have both East Data Center and West Data Center hosts if you take a look. The one we're going to focus in on is this VMware View Desktop, which is actually running down here. So if I take a look at its IP address, it's 224.246.
Right.
And I jump over to the actual View Desktop, and just we like to rule out any smoke and mirrors. We take a look, and that's the actual IP address of the desktop I'm located in. So what we have up in the top right here is we've got an ICMP going. We're just pinging it from outside, from the internet. So I'm logged into this VMware View Desktop just like I would be a customer coming in and using this VMware View Desktop. So what I'm going to do, if you take a look right here, it's over on the East host right now. I'm going to just simply drag and drop it over to the West host. And what you're going to see as this happens down here at the bottom from a task perspective, you're going to see that when this hits about 60% down here, you're going to see a little bit of glitch over here. As you saw, we're going to lose about one ping, maybe two. But the whole point behind this is that I statefully move my device from one site to the other site seamlessly, and the end user didn't even notice that happened. Right?
Yeah, so this is what the end user's seeing right here, the video piece here. And just watching something on here, they didn't notice anything, and you move that.
And it could be any workload. It could be a web server that you're hosting. It could be application database server that you move from one site to the other. One of the other things we really wanted to put into our architecture was security, because at the very minimum inside of a data center, you need some sort of physical security.
That's what gets left out. People have been doing vMotion, and I mean, it's like, that's fine, but now to get it to work, we have to really not have any policies.
Well, you would need some sort of policy on the actual virtual machine, which some people aren't, some customers aren't really, really like that sort of a setup. So what we wanted to do with Lisp
it adds a humongous administrative workload too. I mean, where's your flexibility?
Absolutely, and then where's your management points and everything else? Yeah, I totally agree with that. So what we wanted to do, since Lisp multi-hop came out, we wanted to stretch an ASA cluster between our two data centers. So that's what we did. So the next little piece of the demo I'm going to show you is that I'm actually going to deny. I'm going to have a security policy. Now this security policy, if you take a look right here, is I'm going to deny ICMP just to that workload. It could be any security policy, but I'm just going to deny ICMP. I'm going to go ahead and apply that, save it, and then I'll go over here, and what we're going to see is we're going to see ICMP start dropping. But what we're also going to see down here is we're going to see we're still connected to our workload. So that all being said, the next thing I'm going to do is I'm going to move it back seamlessly. I'm just going to drag and drop, move it right on back over to the East data center. And as I move it, as it moves from one site to the other site, it maintains that security perimeter. One security perimeter, two physically different data centers, one logical data center we're creating here. So as you can see, it's moved from one site to the other. Now he's over on the east site. I am still dropping my ICMP because that's the policy that I put forth. And I'm still connected into the virtual machine here, the VDI desktop. I'm actually going to remove this policy just to complete the whole demo here and show you that we did absolutely apply that security policy. As you look in the top right here, ICMP is starting to work again.
What's the catch, man? Because this, obviously, we haven't been able to do this for a long time, and I don't see you putting any new gear here. What's going on behind the scenes?
A lot of times it's about putting the right pieces of gear together and formulating this integrated architecture between different OEMs. And that's one of the huge values that we bring here at Worldwide Technologies. We can take all these different disparate OEMs, put them together and create a holistic solution. From a technology perspective, a lot of these technologies were somewhat new. Lisp is obviously new and still getting somewhat developed. It's a lot better off than it was 2 years ago when we first developed this, but there's definitely been some challenges. There's been some bugs we helped work through, helped Cisco, helped EMC, helped NetApp and VMware. And I think us going through this process of figuring out how business continuity and data centers, connecting two data centers acting as one, has really helped not only technology industry, but also helped us understand how to make this type of architecture happen for our customers.
Okay, I like what I see here. Still got some hard questions for you, but we're out of time. So I actually want to bring Wayne on, okay. and then let's really kind of sit around and kind of head shed this thing and try and figure out what it takes to actually get this honest to goodness in the data center and what are some of our positive negatives. So we see a lot of positives here, but there's never all positives, right? I mean, it's like I love my wife, but then she comes with her mother-in-law, so I'm like, oh man, So Joe, thanks, man.
Yeah, thanks a lot.
One of the biggest rules for rolling out new stuff is to test it. When you can't do that in your live environment, that's a recipe for failure. So you might come to a place like this. It's the Advanced Technology Center, or ATC, operated by Worldwide Technology. A successful network requires a lot of technology from a lot of different vendors. The engineers here have a simple objective. They design integrated systems that solve business and technical challenges. Well, here at the ATC, you can work with them for any product or architecture being considered. You'll find the latest collaboration, security, data center, and networking technologies across 4 distinct engineering groups: consulting, IT operations, professional services, and proof of concept. Well, these experts work with their peers, be it manufacturers, customers, and partners, to form a complete ecosystem of thought leadership. The ATC utilizes a multi-tenant cloud infrastructure addressing the introduction, evolution, and life cycle phases for a given technology or deployment. It's organized into 4 groups of labs: research and development, test, training, and integration. The research and development, or R&D labs, allow ATC engineers to evaluate new unreleased technologies, perform comparative analysis as well as benchmarking. They will test beta code, new software versions, and evaluate early field trial products, providing feedback to a manufacturer's engineering teams. The test labs are housed in an active data center, offering hands-on experience with over 50 products and systems, including demonstrations designed by ATC engineers. Knowledge gained through these labs will often be shared in the training labs. From formal training to simply scheduling some time with a certified engineer, you can get access to all forms of education, live or on demand. This includes interaction with solution experts as well as access to a huge library of documentation. And finally, this brings us to the 4th lab, integration. With locations available around the world, this is where they will pre-stage equipment from an entire data center while a new facility is getting ready to receive it. It's also a good time to pre-configure what is often thousands of network devices, rack and stack components to create ready-to-deploy systems. It's good to know that there are partners adding this kind of value. I mean, these are all services that we can take advantage of in some way. Shared knowledge, reduce risk, all good things helping us drive better success, reducing that mean time to value that we all seek from our increasingly complex projects. Okay guys, so each one of you have brought up a number of key points. There's some specific overlap because we're talking about some very key design principles. And I really want to make sure that we don't lose any of those things. So I thought it'd be good if we got together, Jimmy Ray and I talked about this earlier, to see if we could really nail down what we thought were best practices and make sure that these are the key elements that anybody should be walking away with and taking back into their design efforts. And so I've got 5 of them here. If you'll permit me, I'm going to go through this list. So number 1, I'm going to ask you about this, Joe. We'll start with you. Simplify the multi-site design and optimize it specifically to the enterprise environment. And the reason why I come to you is because you guys chose, you had to make choices in your design here on equipment. Why? Why did you make those choices?
What we did is we took a look at what was out there and what was easy to operate. We chose some of the different products that you see in our architecture to fulfill those buckets that we talked about earlier. 2 of them from Cisco, Cisco Lisp and OTV. 2 newer technologies as well, and a data center technology that's really been quite prevalent within our customers, especially OTV. Lisp is an up-and-comer as well. But we chose those for their features and functionalities and how they can progress the data center from what it was, what we used to do from a DNS structure before, to what we're doing today, especially from a Lisp perspective. OTV solves a different challenge, which allows us now to extend layer 2 intelligently without adding a bunch of other technologies in the mix as well.
Does that bother you at all? Because it was a little different from your design.
No, those are consistent with our design, and in addition to that, both the UCS and the Nexus 1000V provide the ability to port applications without user intervention. So we have port and security profiles in the UCS platforms that are included in both of our solutions, as well as the Nexus 1000V that allows us to move things around maybe from one setting to the next without having to re-IP the whole environment and being able to preserve that, which is what our customers are asking for.
And I think that's an important point there that you made, Wayne, around the Nexus 1000V, that allowing us to keep that same security profile and statistics as a virtual machine moves from one site to another or one host to another.
Yeah, but come on. We don't need to turn this into a Cisco commercial. I know it's a Cisco show and stuff, and I don't know if we paid you guys to do this design. I don't know how it works. But honestly, really, for the engineers out here watching this show, why did you pick Cisco? Was it the best, or was there honestly we actually commissioned this design to be happening? Was there something that we brought to the table that really made that big of a difference to make this a reality?
I think those 2 technologies that we just talked about, Jimmy Ray, really allowed us to take this current design for distributed data center and move it to the next generation of distributed data centers to allow for that more active than we could have before. Cisco was a huge part of that, but not the only part of that. There were some other OEMs a part of that. NetApp, EMC, VMware, Microsoft, all part of this ecosystem that we've developed around this reference architecture of these different pillars or buckets that we're putting this technology into.
Yeah, if Wayne did pay you, let me know, because I can't get a dime out of him, and so there'll be an inconsistency there we need to address. All right, number 2, minimize disruption to your critical applications. Wayne, what do we mean?
Yeah,
Isn't that obvious?
In the end, it's all about the applications, and it's all about being able to provide business continuity and moving those applications around between multi-site topologies. Joe did a good job of talking about all the different vendors that are involved, storage, application services. And in the end, being able to move those applications around without disruption to our external users is the most important thing. The critical point, though, is any weak link in any one of those services, whether it be a firewall, a load balancer, a network switch, a UCS server or competitive server, or the storage piece, can bring down that business continuity solution. So it can take something that we try to move without disruption and cause a disruption. We've integrated all of those different vendors together in these validated designs so our customers don't have to.
And it's a very important point around making a very holistic architecture that everything works together as one large system. And not individual pieces and parts and individual products that do one certain task. They all have to integrate together.
Well, that's why I'm glad we're here, because it does take a lot of different products. It can't all be done just with Cisco.
Yeah, but but here's the thing, though. So now, if you're looking at that kind of stuff, guys,
right,
and we're looking at this from an application perspective,
yes,
are there certain applications that have to be certified to run on this type of solution? Then, I mean, is it like I can just kind of put an application on here? Or it's like, well, you can only put this version of Oracle and that version of, Plaintree or whatever the case. How application-centric do we have to be?
I think that's a great question, because the way we've architected the design is to support both single-tier and multi-tier applications. So we have web, application, and database tiers. We know that you can mix and match components of the data center to be able to provide maybe L4 through L7 services like firewalls or load balancers or different storage choices within this framework. So we expect different applications to be able to run within this general purpose architecture, and you could have confidence with each of the choices we've made in each of the tiers of the application to insert the application of your choice. So whether it be SharePoint, SQL, Oracle, any of the traditional enterprise applications, we have a framework to allow you to onboard those applications and then preserve business continuity and workload mobility performance that we validated. It's pretty solid. It goes beyond what typically you've seen in the past in terms of delivering the next generation of business continuity.
Yeah, all right, now I want to make sure we get all 5 points in here. Number 3, I'm going to come to you because you had me add this one back in, and you wanted it worded somewhat specifically, so I hope I get it right, but it was that we must take into account this focus on reduced CapEx and OpEx. Now, that surprised me a little bit coming from an engineer. Why was that important to have as a best practice?
Well, not only do I work here at Worldwide Technologies, but before I was actually a customer and I ran a bunch of systems. And the OpEx piece is probably one of the most important aspects of designing any type of architecture. If I can't operate it very simplistically and easily and very easy for my operations folks to go through and manage, then what am I really building? A complex environment that nobody can manage, right? And so we really have to take a look at that. If we can make this operationally simple, this type of architecture, where we're doing what we saw before, which was a little drag and drop to move a workload or allowing that workload to HA and show up at the other side if we have a site failure, it makes it very simple to operate. Now we don't have things like run books and scripts and all these other things that have to be done in order. Now the technology takes over in place of those different things.
Well, now this may tie into the point you were making earlier, and it's really number 4, which is we've got to tie this into the focus for the business, tie this into the business objectives. You were talking about, is it RTO and RPO and how important those type of measurements are as goals?
Yeah, when we work with customers across the globe, one of the first things that we do is have them establish for each of their applications a recovery point objective, how much data they're willing to lose if we're to move an application or recover it, and a recovery time objective. How much time are you willing as a business to have that application be out of service while this sort of stuff is happening? We work with customers to establish both of those targets, and then we map those applications to different designs to achieve those targets. Achieving near zero outage in terms of data and time obviously is much more expensive and can be more complex. You don't want to map all of your applications to the most complex and expensive topology. We offer both multiple types of designs within a single construct to be able to say, okay, I've got very business critical apps. I'm going to map to this particular design within this data center. And then I've got other less critical apps that may require maybe 10 or 15 minutes of recovery time that we can be out. And we can save both OpEx and CapEx in that way.
That is the most important point as you go down this journey of a distributed data center or business continuity site, where you really need to map those applications to the recovery time objective and recovery point objectives. We saw that customers that don't do that at the start, everything goes into that bucket and they just price themselves out of a business continuity strategy. So that is the first thing that we do when we talk with our customers.
So when we talk about the next generation of workload mobility and business continuity, we've got a single data center design that offers you multiple choices based on how you map those your application to that criticality. But you got to know where you're going.
Obviously, you can't. You'll never get there if you don't actually put a destination in place. It's principally makes a lot of sense when you start thinking about it, because usually I go, well, how much data center design? Well, I want the best. Just please make it all. You go, well, that's unlimited in terms of how expensive that could get in an active
Hey, before
design.
we go on the last one, though, I do have a question for Joe, because Joe, you mentioned, I can't let you off the hook, man. You mentioned something about simplicity. And let's just face it, man. Let's say it's Friday night, had a couple beers. I get called in, got my buzz on, have somebody drive me in.
Typical Friday.
You know,
Typical Friday.
Typical Friday in the Purser household, and have somebody drive me in to actually, because I got to fix a down network. You said this is a simple solution.
Yeah, I mean, once you build the foundation around this, now you're plugging in different applications to ride upon this foundation, right? You can't build a house without a foundation. And what you're building here is the architecture or the foundation to put your applications or your house on top of. So now that house can be built structurally sound. That being said, what we need to do when we build these types of architectures is that we need to minimize those 2 o'clock in the morning on a Saturday morning call that you may get, right? Because you're out and having a good time. So we want to make sure that we architect this thing to be very resilient as well. so it can automatically recover dynamically without having any.
Okay, that's a key
intervention.
word.
Yep.
That's what. So you're saying automatic.
Yep.
It's doing this actually happening kind
Sure.
of.
Yeah.
And that's a good final point, because I don't think we even need to spend too much time on this, because we've said it in a lot of different ways, but let's call it out. Number 5, simplified orchestration with no manual intervention. To what
Yeah.
you said there. Wayne, final point on that?
Yeah, I think what we're delivering to customers within our Cisco validated design and the solution here at Worldwide Technology is the ability to really have the next generation of business continuity. And what is that? And workload mobility. It's being able to perform these migrations and business continuity without manual intervention. It's about removing some of the complexity and providing orchestration and automation of these moves. So in the past, where you had to have many manual steps to be able to achieve this, as we saw today with Joe, we're able to point and click and move an application. But most importantly, the rest of the application environment is also migrated or impacted by that move. So we can preserve the application environment, the L4 through L7 services, the network containers, the QoS, all of the things that the application actually runs on, being able to preserve those things, even though the application may move to a different city, we're extending this workload mobility to the next generation, which is up the stack and across multiple sites.
And to piggyback on top of that, that was very eloquently said, but to piggyback on top of that, what we want to do is take 2 physical data centers, make them one logical data center, but provide a one data center look to our application, so they don't quite know that they're a part of these 2 physically different data centers.
That's a fantastic point.
And that's where it all comes together, right? Which is at one level, and it's so simple to say, a little bit different to do, is we're just talking about one data center in 2 different locations. And you got 2 drastically different things you have to take a look at from a distance perspective, whether it be metro Ethernet or some larger geography that you've got to take into play. But no, very well said. Wayne, I want to thank you for bringing this show to us. It was
welcome.
you and your team that brought us and helped begin educating us as to how this was different than data center interconnect shows we've done in the past, because it is truly different, and you guys have worked really hard to do it. You guys worked really hard as a partner. Thanks for letting us into your facility today and give us a chance to look around and doing what you do for customers. You guys are huge. I just can't believe all the work you do, and it's very, very impressive. So anyway, Jimmy Ray, thank you, of course, as well. We'll see you around. Hey guys, thank you for watching. My name is Rob Boyd on behalf of Jimmy Ray Purser and the rest of the team here. We thank you for watching. As you know, keep up with us online for this show and all the others. We'll have information on the blog where to get more information, how to find some of the design guides, as well as more information, because basically we never cover it all on a single show. But we appreciate you watching. Let us know what else you want to see, and we'll see you on the next one. So, in a recent survey,
Sorry, I was getting in character.
okay, sorry.
Face.